take a look at is number 22 from the homework. It's solving systems of linear equations graphically. And the problem is presented here. We've got two linear equations and we want to find the intersection if there is one, and then we want to graph the solution. So I'm going to hop over to a different screen here so that you can see my work as I solve the problem. Okay, so I've set up the two equations here. I've got equation 1 and I've got equation 2. Now to solve these equations, I can eliminate one of the variables. I'm going to eliminate the y variable because I've got a plus y plus 3y and a negative 3y. Those will cancel out to be 0y. So if I simplify this, what I've got so far is 7x plus 0y. Well, I don't even need to write that down if I don't want to, so we could get rid of that. And then on the right-hand side of the equation, if I keep adding these equations up, I've got negative 6 plus 20, that would give me 14. Now, to isolate x, I need to get rid of the 7. On the left-hand side, I have 7 times x, so the inverse operation of multiplication would be division. So let's divide both sides by 7. Once I do that, on the left-hand side, I have 7x divided by 7. Those 7's cancel and essentially give me a 1x. On the right-hand side, 14 divided by 7 gives me 2. And the final answer here is x equals 2. That means that these two lines, if I graph them, do intersect. And they intersect at a point x equals 2 and y equals, now let's figure out what the y coordinate is. If we go back to equation 1, I'll use that equation. That looks quite easy to work with. I'll plug in my x value, which was x equals 2. So we've got 3 times 2 plus 3y. We don't know what is y. That's what we're looking for. And on the right-hand side, we have negative 6. So if we simplify, 3 times 2 is 6 plus 3y equals negative 6. Subtract 6 from both sides of the equation. And what we have, come over here, we have 3y equals negative 12. Therefore, y equals negative 4. So the intersection point is at x equals 2, y equals negative 4. And we can write that as the ordered pair over 2 down 4. Okay, so if we want to graph these two equations, we know one of the points that lies on both of these equations is 2, negative 4, but we need some additional points. So let's go through and see how to find some additional points without making our life overly complicated. So I'm going to erase part of the screen here to give us a bit of space to work. Okay, so let's get back here and I'm going to be working in red. So let's work with equation 1 for a moment. So equation 1 has an x and a y intercept. If I look at this equation, it will be quite nice if I set x equal to 0. And when x equals 0, we have 3 times 0 plus 3y equals negative 6. This will give me the y-intercept. Okay, solving this equation, we have 3y equals negative 6 or y equals negative 2. In other words, we have a point on the line for equation 1 of over 0 down negative 2. And of course, we have that intersection point still in our life, which was 2, negative 4. So that tells me how I could plot that line. Okay, and we can do the same thing over here for the second equation. Make a little bit of space. So for equation 2, looking at that equation, we've got 4x minus 3y equals 20. Now, I don't want to get involved with fractions if I don't have to. So I think it's going to be easier to set y equal to 0 because 4 divides into 20. That's going to be much nicer. So over here, I'm going to look for an x-intercept. I'm going to avoid some fractions. Now, if you do get involved in fractions with MyMathLab, it's going to be very hard to graph the line. You know, because if you're trying to get 1/3 or 2/3, it's too tiny on the screen to really differentiate that. So that's why I try to stay with whole values here. And I suggest that you do the same. So we'll set y equal to 0. And if we do that, in equation 2, we've got 4x minus 3 times 0 equals 20. Let's simplify. We've got 4x minus 0. Well, I don't even need to write that down, do I? And carrying on, we've got 4x equals 20, dividing by 4 on both sides. It gives me a final answer of x equals 5. So on equation 2, if I'm going to plot that up, one of the points is going to be over 5 up 0. And then, of course, the intersection point, we already found that point. That's 2, -4. So now we've got some really nice numbers. We can come over here in MyMathLab and plot these up. MyMathLab, I just wanted to show you the solution. So here I've plotted the two lines, and the way that I did that is, let's take a look at this line right here first with the negative slope, the one that's going downhill. So the way I plotted that is I chose this nice intersection point, which is over 2 down 4. So I clicked on that value, and that was a really nice choice because it has integer coordinates. So I didn't have to try to get half of a box or something in MyMathLab. I was able to click right on the crosshairs there. And then the other point that I chose was the y-intercept. So where does this line cross the y-axis? And that happens at this point right here, which is over 0 down -2. So I clicked on those 2 points, and then that gave me the line. You know, I could have chosen other points, but if I tried to click on something else that's in between the boxes, it's very, very difficult to get the problem correct. And then for the other line here that's going uphill that has a positive slope, again, I chose the nice intersection point, which was over 2 down -4. And then I chose the x-intercept, which was over 5 up 0. And those, again, were really nice whole number values. Notice that I could have tried to choose the y-intercept, but that's in between the -6 and the -7. Who knows what that value is? And so the chances of getting that wrong would be very, very high. So try not to plot in between the grid lines, because it's very difficult to get exactly the right spot. You do want to plot in MyMathLab with the integer values.